I think this is going. Yeah, I think this is working right. Okay, well, I guess I can start. So the idea is there are lots of lighting systems, I guess, out there that exist for ultralights or for paramotors, but either A, they're too expensive, I guess prohibitively expensive for what they are. Either it's just a strand of LEDs or a simple strobe. And it seems that like the strobe will cost $50, $100. I think they're great systems, but I don't think that they necessarily do what I'm looking for. So I decided, I have I have quite a bit of programming background. Is what I do. I'm a software developer, but I have a little bit of electrical engineering experience. So I figured I would use like an Arduino board to prototype some sort of modular lighting system that included strobes, maybe on the cross beams of the frame of the motor, and then maybe having like a strand of LED lights around the ring, around the cage, like RGB LED lights that were somewhat controllable, I guess, or at least you had the ability to switch between different modes. But I think the key is number one, that it was power efficient. Number two, that it was like cost effective, and I wanted to open source it. I guess so that people could improve on it or that they could build it themselves. I guess the idea with the project is not really to make to make it to sell it. It's more of just to make it for the community so that people can easily get FAR 103 compliant as far as flying it at sunset or at dawn. Easily and in a cost-effective way, I guess. There's lots of strobe systems. Skyflare has one of them. Aviator PPG has one. A buddy of mine sent me one earlier today that PPG Smoke just released. And they're all good, but I think that again they're just a bit cost prohibitive. And I don't know. I guess it was just, if anything, it's just some kind of project that I can ultimately build myself and share with the community. So, all right, this is my first stream here, so we may have some technical difficulties as we get this all set up. All right, let's see if we can do this. So, I've been using an Arduino Uno for prototyping, and I've had some good success so far. I picked up this. This is an Adafruit Trinket M0, which has the same capabilities as this Uno. It doesn't have as many pins on it, but the processor in this Trinket is a Cortex M0, which is significantly faster, has more RAM, has more storage than this Atmel AT Mega. So anyways, this is basically what we're starting with. I may do a little bit of prototyping on here just because it's a bit easier to interface with. But the goal would be to have a form factor, something about this size, so that it could be, easily stowable, right? Whether it's like in a side pocket or mounted somewhere. And obviously there would be, a box around this, some kind of enclosure. And then you would attach the battery, and then you would attach the multiple, however many lights you wanted to have. it would be modular, right? So you could choose to have maybe just a single strobe, or you could choose to have a strobe and a ring, ring of colored LEDs, or you could have 2 strobes. I guess ultimately that's one of the goals of the project is the modularity of all of it. So sort of where I thought a good starting place would be, let me see if I can switch to the top-down view here. So I fly on a mini plane top 80. So you obviously have your ring and your harness somewhere here, and you have your crossbars like this. Obviously a couple of pockets in a reserve. So in proper aviation, you have your navigation lights. We're on one side, and there's specs as far as like viewing angle and things like that. But effectively, one side you have a green navigation light. I don't have a red marker here on me, but on the other side you have a like a red navigation light, right? And then inside of those, you have the strobes, right? And then the strobes, there's positions on the aircraft in which the strobes need to be placed. But ultimately, the idea that I originally had was to have some sort of LED strip on either side, and then have the navigation lights right at an appropriately placed angle, right? And so then we would have red and green, or basically a strip of green here and a strip of red there. And then if you're looking at a cross section of these crossbars, right? You could do a strip here in the front that would be shining this way. You could do a strip on the top, a strip on the side, I guess that would be the back, and then a strip on the bottom. And then you could pretty much just encase this with some clear shrink wrap, like or shrink tubing, and then it would pretty much be weather resistant. I wouldn't say weatherproof, but it would definitely be weather resistant. So you'd have these modules here, and then you'd run your lines down the sides, and then depending on the motor that you had, you run them to the pouch or whatever, wherever you wanted to mount the control unit. So this would be effectively two strips plugged in, right? Because we would need logic, I guess, to control either side. And then something like this. So the strips that I've been testing with so far are these. Let's see if I can get this closer to the camera here. It's a bit dark. Let me see. So there are these Adafruit RGBWs, which is nice. So in my experience and in my testing, these standard. So here's a standard RGB LED strip, and while you can get a full white by lighting up all of the LEDs in each one of these units, I found that it wasn't really that bright, as far as bright compared to a true white SMD, right? And so Adafruit makes these, which are they're called NeoPixel RGBWs, right? And so they have the RGB chip right here, you can see in the clear space, but it also has a dedicated white driver as well. So what I found is that when lighting up, basically when I wanted to do a strobe, I could light up the RGB full white and this white SMD full white, and it was significantly brighter. I mean, it was extremely bright. And when when I have a full like 5 volts, and I tested at 5 volts, and I think it was like 3 amps. It was pulling 3 amps when fully on. I mean, these things were blindingly light, which is good, right? So the idea is you would mount, I guess maybe one of these on each side, like in this configuration here. So you'd have one, 2, and then 2 on the other side. I think ultimately you need to test to see if one strip was long enough, or if we needed more, because this is eight 8 LED chips here, and again, in my testing they were pretty bright. Now what I have also are these, and these are the NeoPixels as well, and they're RGBW chips. You could cut these, I guess, and make the strip however long you wanted on each side. I guess I guess it's highly dependent on the motor unit that you're using, and how bright you want them to be. But these are relatively power efficient. As long as you don't keep them on solid all the time. I would say you could run. In this configuration, you would have basically 8 if you ran both sides on all sides of the crossbars. You could run them off of a little battery pack, little USB battery pack for hours and hours. I mean, I would say for like 12 hours you could run it. Again, this is a complete estimate, but this is what I've been testing with here. Which this is a let's see, 10,000 milliamp hour battery. I haven't tested. It's saying it can drive 2.4 amps. I lit up this full strand here. This is 144 LEDs, and at 5 volts it was pulling. Again, I think like 3.5 amps. So I don't think this would necessarily be powerful enough to power these fully on, fully white for that long. I think again I need to take measurements and test. But yeah, I guess we'll see. So that's the basic premise, right? So again, we would have these two. Let me go top here. We'd have these two cross beams. Again, one showing green and one showing red, and these may be flip-flopped. This is red. Towards the front, right, and then on all sides you'd have the bar, and then with whatever pattern you wanted to, you could activate the strobe as well, right? So every maybe 1.5 seconds to 2 seconds, these would strobe in just a standard triple strobe or double strobe pattern. And then the controller board, this would be built out a little bit more. Again, this is just for prototyping. Once I settled, I guess, on a final design, I think ultimately it would be nice to be able to build everything right off of this without having to have a custom PCB. Just because of the open source factor of it, it would be nice for people just to be able to pick up like an M0 or like an Uno or something, drop the code on and run it. What I wanted to do, I picked up a couple of these OLED screens, and these are really nice. Let's see if I can show you. So these are like, I don't know, about the size of like, I don't know, 2/4 or something like that. And it'd be nice to build an enclosure that housed both the PCB and this OLED screen, as well as maybe a couple of buttons, so that you could cycle through modes. This would be, let's say you're flying and this is in your pocket. You can stick this out of your your motor pouch, whatever, wherever you store things. You can see exactly what the mode is. You can see maybe the battery level left, and then you can obviously cycle through each light. So let's say this would be L1, this is L2, and then you have your strand right around the edge, and this would be L3. And then you could set different modes for each of these different lighting systems directly on the screen. And then these little OLED boards, they don't really use much power at all. And then we could obviously just turn it off after some sort of delay, which I think would work pretty well. Yeah, so that's the basic premise. A modular lighting system, that was open source, that basically anybody can order the parts online, and build it themselves if they wanted to. They could modify the code, and maybe we can have some other developers in the community maybe come up with different design patterns. And there's a bunch of patterns online. that you can do with these little LED strips. In my testing, there's a bunch of different rainbow patterns you can do, and all kinds of trailing lights. Basically anything you can imagine you can do with these little things. Yeah, so I think the next step. I haven't done any prototyping with this M0. It's like it's an AVR board, so it's a little bit different than these Atmel chips. This thing is ridiculously easy to start programming on. Basically, I plugged it in and I had uploaded a sketch onto this thing in like 10 minutes, which is good. The reason that I want to use an M0 is because what I had found with the Atmel is that whenever I tried to drive, I mean, even on these, because these are 144 LEDs per meter, which are really dense. I have here are some that are, I think these are 60 LEDs per meter, and you can see, if I can get these out, you can see the spacing difference there versus here, right? And I don't think so. The top here is, I don't know, I guess 60, and then these are 144 per meter. I mean, obviously the color and the brightness is so much nicer with the 144 per meter strip. I think once I begin testing this, I'll see if it's feasible to use these. I mean, all of the other lighting systems on the market are using these strands, or even, I think there's like a 30 LEDs per meter strand as well. And obviously, I guess it would be the power consumption factor would be the limiting element here. I have another strip up here that I've been testing with as well. These are Adafruit LEDs, and these are just, I think I got these on like Alibaba or something. These are like really cheap Chinese knockoff SMDs. These are nice because they're sealed in this like silicone, I don't know, some kind of silicone coating here, which is really nice. But again, I don't know how good the quality, and these are only RGBs, these aren't RGBWs. And then all of these are obviously 5-volt strips. So I think there's a lot of there's still a lot of like sort of research and testing to do in the process. I think the first step would just be to focus on getting just these two side modules written and working. And then maybe releasing something with that, and then having because this will be pretty easy to power. It's relatively low power consumption. And what I thought about as far as having them on all four sides like this is, the pin layout, right? So on these boards or on these strips here, you can basically cut them at any point along. Let me switch to a different view here. You can cut them at any point along the strip where you see those little copper contacts, and wire. You can basically just solder, or they make special connectors where you can connect two clips together. That's the wrong view. So the idea, let me start your paper here. The idea with this section here would be that you would have you would obviously be required to have this front panel, but from a wiring perspective, you had your LEDs, and you have your 4 contact pins. Either we find some sort of JST connector that's really low profile, which I've been looking for, and you can get like 1,000 of those things for relatively cheap. And the JST connector would just patch onto the end of this. We could make some sort of pigtail effectively that came off of here, and then this would be a JST connection to another strand. And then the idea is you would be able to do this indefinitely for whatever made sense for your motor, right? And so if you only wanted to have, so let's say this is going to battery, right? Or this is going to the controller, and then this is your controller box. the idea is that you would have at least one strip here, and this would be the minimum, and then you could basically daisy chain as many as you wanted on the end of this, and the controller would just continue to feed the signal on all the way down. So you would take this configuration, and again, as on your crossbeam, as a cross section of your crossbeam, I guess this is my poor attempt at doing a 3D drawing here. You would have one board set up here, and then you would somehow run the wires. I don't know. This is where it gets kind of tricky, is figuring out how to run the wires properly. They would go on top of there, and then one in the back and one at the bottom. So again, in the cross section, you'd have one board on top, one board in the front, one board on the bottom, one board on the side. And then you would have to figure out how to, and again, I think that's the advantage of having these as a pigtail, is that you can get some kind of extension wire. You can vary the length of these wires to ultimately connect these whatever way made sense on your particular motor. Because I think I don't think there's going to be one configuration that makes sense for every setup. Yeah, so that's sort of the system in a nutshell, a modular LED system in which has some sort of visual display using those little OLED boards that you can then modify the the pattern that's displayed on each output pin. Again, this being L1, or you could call it whatever, strip 1, and then change the pattern on each. So you could have standard strobes here on L1 and L2, and then L3 could be doing some kind of crazy rainbow effect, right? Or you could have L1 and L2 strobing and then have L3 completely turned off. Or if let's say you land and it's starting to get dark, you can put them all into a full on mode to help sort of light the area around you, so you can pack up your wing. And I think these aren't really exclusive to paramotors. I think that they could be used with fixed wing aircraft as well, fixed wing ultralights. I'm sure that there are much better systems out there, but again, I think the open source factor is kind of nice, and also just the ability to do it, to buy these things for relatively cheap. The most expensive part is these LED strips. These are again Adafruit strips, so they're particularly expensive, and they're really they really have a really high density. I think if you found a good quality supplier of these, like from China, that would bring the cost down even more. I think this strip was like $50. Probably I think this one, this is also an RGB, this is not an RGBW, but I think at this density, the RGBW strip was like $30. So, you could do, let's say it takes you 3 meters to do your entire hoop. So what is that, like $90? And then whatever your costs are for the parts. I think this trinket was like $6. And then the OLED boards. I mean, ultimately, I think you could do it for a lot less than the competition out there, and have an arguably better product, right? With the ability to configure the way you wanted it to strobe, and having the option to add on different modules, right? And I guess that's ultimately the difference between this and everything else that's out there. Is having the ability to set the different modes and add as many or as little lights as you really wanted to. And I think probably four output pins would make sense. Again, because you wanted to keep the board compact. And then this trinket here, we're going to need a couple of pins for the screen. Some for the buttons. I honestly don't even know if we're going to have enough pins on this board. We may have to use a larger. I got this. This is another M0 board. This is some kind of Chinese knockoff. I don't know. I tried looking online. It's XYZ Duino board. There's pretty much no documentation online about it, but this is also a Cortex M0. It's a larger. It has basically the chip has more pins. The SMD has more pins, so you have more digital pins and PWM pins here to work with. So the final product may. I mean, I would really not like it to be this big. Obviously, this is a development board, so we could get a custom PCB made for pretty inexpensive. But it would be nice to be able to get all the pins on here, or to be able to use something in this form factor for the project. But I just don't know yet if it's going to be possible with the screen and the buttons and 4 outputs. I guess at a minimum you could do 3 outputs. Again, I just think it's going to be a trial and error situation. Just see what ultimately we need with the final product. Yeah, these little M0 chips are significantly fast. I think it's like 9 times faster than these Atmels. So, running running this 144 LED strip, I got it running on. I did like a rainbow dance pattern. I don't know what it's called, but some kind of rainbow chasing pattern. And at this 144 LED density, you could really see the little chip here struggling. So I imagine that if you were to chain, let's say 2 or 2.5 of these together, as well as these side strips, that this thing would probably either A, run out of memory, or B, just be just maxed out on the CPU trying to address all of these individual LEDs. So I mean, there's no reason not to use. The price is actually the same on both of these two chips, on both of these two boards. So I can't really see a reason not to use the more powerful processor in the M0. Yeah, so that's ultimately, I guess, my logic going so far with the project. If anybody has any feedback or any recommendations, or if you see something that I'm doing that's horribly wrong, definitely reach out. I'd love for this to be like a community-driven project, so that I can build something, or we can build something that people actually use. I'm building this ultimately to solve a problem for myself, but it would be nice if other people could also use it. And again, I think that you could ultimately make this entire thing. Let's say you didn't want the big LED ring, and you just wanted it for the FAR compliance. I think, I haven't run the numbers on it, but I think that you could get the chip, and we could even do it without a screen. You could just have this sort of minimalist version of it, where you just have the controller board, your battery. Most people have these batteries just lying around, and maybe 2 or 4 LED strips on these crossbars or wherever you wanted to place them, and you could probably do it for like under $30, which is significantly more, and it would be compliant. Like I said, these LEDs, when you have both the white SMD and the RGB lit full, these things are ridiculously bright. So I mean, under 30 or $35, I think is kind of a bargain compared to the alternatives out there. I mean, I've seen, Amazon has, I've seen a bunch of pilots on YouTube pushing these things. Well, not really pushing, but they recommend them. They're these little, like life preserver strobe lights. They run on like a AA battery, a couple of AA batteries, and you can't really see those things. So I don't while I think you have a strobe, I don't think it's actually improving the safety of your flying, which I think this will do, and it's like roughly the same price. I don't know how much those things are. Maybe they're like $15-20, but even if anything under $50, I think is a pretty good deal for a system like this when you compare to things like the the Skyflare system, which I don't know. Last time I checked, I think it was like $200 or $300 for the dual strobe setup. Yeah, so any feedback that anybody has, I would love to hear. I don't know how the stream works. I don't know if this gets saved as a video or not, but I guess leave feedback in the comments or on the forums, and we can kind of get the project started. I think the first thing I'm going to do is just start to solder on these pins here so we can get this mounted to a breadboard, and I guess just start hacking on this thing. Yeah, I have the Arduino IDE set up here on my computer. I think I can do a screen share. I hope it's readable. But yeah, I guess we should just get started. Let's see how far we get. Maybe the next 20 minutes, 30 minutes or so. So let me just kind of clean up this space here. So these little boards are so easy to work with. I have a decent electronics workstation set up here, but I mean you can work on these things with you get a little half-size breadboard like this, and a couple of jumper pins and a really cheap soldering iron, and you could basically just build this on your own for cheap. So I've got to see how many pins this is. I think I missed one. I hate these little breadboard pins. They never break where you want them to. Alright, I think I got that. Let's see which angle is better. I'm not sure. Close up. So I like to mount these things on the bottom of the chips, so that the pins are sticking out of the bottom. That way when I mount it to the breadboard, everything is obviously laid out on top. That usually works best for me. Alright. And we'll get this other piece here. And of course I cut it too short. Let me see if I have some more. I do. There's probably an easier way to do this. Okay. Oh man, that just shot across the shop. So this is a pretty straightforward step. We're ultimately just trying to, I guess I can put these here. I guess you're ultimately just trying to solder these jumper pins through these through these through holes here. These little boards can dance around quite a bit, so you kind of have to get like a little spot solder down and hope for the best. Okay, so I got a little solder, got my soldering iron here. Just gonna tin the tips. I would usually use flux, but I think we'll probably be okay. We'll see. Famous last words. Okay. I'm just trying right now to get a little tack in place. I don't think you can see that. Let me see if the top down is any better. Not really. These boards are so small. And I'll put one on the other side too, and then I'll try to bring it closer to the camera. Alright, you got the good one there. I'm trying to make sure that the pins stay relatively straight. Okay, so I got a single joint, and obviously they're not straight here, but you can kind of see. You can't really see. Ultimately, I just put two solder balls there on either side just to hold it in place, and I'm going to go back now and just adjust the orientation so it doesn't look like a spider like that, so the legs don't stick out. I want them to be sort of perpendicular to the board. All right, so that looks pretty good. So now I'll just go in and fill in the rest of these pads with solder. Okay, I got that side. When you're working with these little boards, you don't want to hang out on these pads for too long because they're so dense. All these little, there's a bunch of resistors and this SMD here, this chip. So you just don't want anything to get overly hot. If your iron's hot enough and you have decent solder, everything should flow pretty quickly. As I say that, I can't get this last one. There we go. Yeah, I mean, I wasn't even soldering really close to the this little USB header here, but it's pretty warm already. So that's it. We have I think this is a pretty good base. See if I can get this in the camera. So you can see it's relatively, it's like at a nice right angle there. So when we mount it onto the breadboard, and then you want just a nice, like a nice cone shape on your solder joints there. And you can choose to mount this on the breadboard however you want. This isn't exactly like Electronics 101 here, but I figured I would talk about something rather than nothing. Alright, that was pretty easy. So this little, so this is again the Trinket M0. This Trinket M0 has three, I need like a pointing device or something here. Has three LEDs on it. There are, there's like a green, or I think this is a red LED here. There's a green LED here. This is your power. Yeah, this is your on LED. This LED is on pin 13. It's actually controllable, but it also, the board gives feedback on this, like whenever you're uploading a sketch. And then what's really cool about this board is there's actually a Adafruit dot star LED here, which is like a tiny RGB LED that is also user controllable. I can't remember the pin that it's on, but yeah, you can actually control it, right? So it's cool. So you can give status indication. So if there's some problem or have a low battery, you can actually change this really this tiny LED, and it's really highly efficient. Cool. So I guess we need to wire up our power traces and our. Let me see if I can get to the top down here. And our data line trace, and then we should be good to at least upload a test sketch to see if we can get this thing working. Again, I haven't tried. I just got the board set up in the Arduino IDE like about half an hour ago, but I haven't actually tried interfacing with these NeoPixels yet. So we'll see if it actually works or it doesn't work. So they recommend, Adafruit recommends putting a 1000 microfarad capacitor on your power line to help with any, I guess, power surges that may come from a power supply. I'm going to be using a, let's see if I can, I'll be using, there's a power supply here that I'm going to be using for testing purposes, but the idea is that I'm going to try to limit my current to something reasonable, since these little battery packs here can only put out so much current. It would be really nice if I can get this thing to run at least the minimum strobes, just without the ring on a battery pack like this, or even smaller, because those lipo battery, these things are usually, if you get a good brand, this is I think an Anchor that I got off of Amazon for like $30, and if you get a decent quality one, there's a lot of safeties in here, which is always kind of a concern, like when you're dealing with like lithium batteries and aviation, is you want something with a lot of like battery protection built into your battery unit, just because if these things overheat and you're in flight, it's basically a lot that can go wrong, and you just don't want to be dealing with that story. So they recommend putting this 1000 microfarad capacitor in line with the power, so I'll be doing that. And then we have a resistor here that we'll be putting in line on the data trace. Again, this is to prevent power spikes running down. Apparently, it's easy to kill like the first pixel on these pixel strips. So you just put this in line on your data strip, and see if I can get that in the frame, and that should help protect you there. So let me go ahead and start wiring this up. We can figure out where our power. So it looks like our battery and our ground runs right here. Get some jumper pins. Just need some smaller jumpers. I guess I could use a little piece of wire instead of a jumper, but these things are so handy. Do I have black? I do have black. That's too long. Okay, well I guess I can just do it with a larger black and a larger red. This jumper is missing its end, so that's not good actually. This is trashed. I guess we can do it white. Yeah, I just bought a bunch of these new jumpers the other day. So I'll do white and red. This one's fine. So I guess we'll go from, so we want to power, okay, so the M0 board accepts up to, I believe, 12 volts in on this battery line. So I'm going to be, like I said, I'm going to be powering with 5 volts. The board itself operates at 3.3 volts, which is nice because it's power efficient. But what's also really nice about this board specifically is there's an onboard regulator which will take anything up to 12 volts down to operating voltage, 3.3 volts. So yeah, we'll do that. We're going to be powering the LEDs not off of the power pins on this board because they don't give us enough current. We're going to be powering it actually directly from the power supply. So we'll have to wire up a circuit for that eventually as well. And I know this is not terribly exciting to watch. Let's see if that's a little bit better. Okay, so we have, let's move these up one pin. Alright, we have our ground and our power. put this cap in here. I don't know that this is going to have to cut this wire down. So again, we're just putting this capacitor on the power circuit to help buffer basically the power that's on this trace. Okay, man, this is janky. All right, these pins on this breadboard aren't tight. I wish they were a little bit tighter. Maybe I could move on to something like this. Let me see if these feel any tighter. No, not really. Okay. Well, that's all right. Okay. And, all right, I guess the next step would be to add our power to the board. And we'll get a couple of additional jumpers here. There's the black one I was looking for earlier. And if you were to hook these up, plug these in while it's powered on, you always connect ground first. Kind of like when you're jumping a car. Okay, so let's go ahead and set our current here. And we'll set, I wish you guys could see the, let's see if I can bring this up a little bit. Okay. Okay, so I'll go ahead and turn this on. I'll try to tilt this a little bit. Okay, and we will bring the voltage up just a little bit. Okay. And this should start. Get this in here. If I can get it in. Of course I can't. Okay, there we go. So now when this gets to, let's see, are we wired ground to ground? Alright, so when this comes up to 3.3, yeah, there we go. Alright, so we got the status LED going. I don't know if you guys can see that. It's basically turned on. So it's good. The board's working. I can see the little dot star in there glowing. And the reset button works. Cool. Alright, so we got power to the board at least. That's good. Cool. You know what? Actually, I'm going to pull this. I'm going to pull these power pins back a few so that I can get additional power off the rail later on for the LED strip. I don't know if this rail connects all the way down. Guess we'll find out. Yeah, sure does. Cool. Okay. Okay, so we have power. So let's go ahead and get the, let's kill power here. And let's go ahead and get the these lights hooked up here. Let me pull this cap down a bit. Let me turn off power. Okay. These little power supplies have a tendency to surge when you first turn them on. So it's always a good idea to have the positive pulled out just whenever you're turning it on. So this little strip has two ground pins, a power pin, and a data pin. So these two black lines are the grounds. The red is, and I soldered this like last week, so this has already been done. Red is power and white is data. These NeoPixels take 5 volts input. That's full power would be 5 volts. You really don't want to apply more than 5 volts to these, otherwise you're going to have kind of a bad time. So let's go ahead and get these wired up as well. Okay, the only thing left is our data pin, and it's just about me picking which pin to power off of. I guess we can do pin 2. I want to pick a non-PWM pin, just so we can see the worst case scenario. So I guess we can pick pin 3. Let me put this resistor in here. If I can finagle my my fingers into this spot. Yeah, I don't think pin 3 is a PWM pin. Okay. That's a pretty ugly job there. I'll have to cut that at some point. And we'll go into data there. Okay, I think we're set. Let me just verify here. Everything looks good. We got our ground to ground, our power to power, and our data behind a resistor, and we're on pin 3. Okay, so this is not going to do anything when I add power, because we don't have any code on the microcontroller. But let's see if I power up and something explodes. Oh, there you go. The lights are doing something. Why are we getting signal here? Are we shorted on something? You guys can see this. Let's see if we can switch cameras. Getting a nice weird color artifact on these things. Sometimes it happens whenever these pins short, but I can't see it shorting anywhere. No. Alright, well, let's see what happens. Let's go up to I see it's drawing already. I don't know if you can see here, 0.1 amp. Let me just validate here that I didn't screw something up. Okay, it's on pin 3. Yeah, I think this is okay. Let me try throwing like a sketch on there and we'll see what happens. Again, this thing just, I guess, could explode. But hey, I guess we'll see. Okay, so I'm just gonna work with like a, I guess like a sample test sketch. Let me see if I can switch to the Arduino board here. Okay. So I'm just going to switch to like a just like a demo sketch to see if we can at least get it to work. Let's paste this in here. So we need to set, we're on pin 3 and we have 8 LEDs. Set full brightness, and then we need to, okay, so this is set to the RGBW. So this in theory should work and cause it not to explode. So let's upload and see what happens. Oh, well, it would probably be helpful if I actually plugged in USB. Okay, so I got USB in. Let's see what we get. Okay. And okay, looks like it wrote. Ah, there you go. Sweet. So it's working. Let me see if I can switch this so you can see it. Okay. It's kind of hard to see on camera here. Yeah, so it's cool. It's working. I was concerned that on this Cortex board it would be a bit more difficult, but it didn't seem to be. And you see, it's, I mean, the power supply is, it's like barely even registering that that it's pulling any amps, which is good, right? So let's try putting all of the LEDs on and see what the amps, what kind of amps it pulls. Okay, so if we comment this stuff out here, I might lose this camera, by the way, just because it's running low on batteries, but if I lose it, I will just swap them out. Okay. And then I think we can set, yeah, I think we just do this. I can do it 255 full brightness. This, I think in theory, should just set our board to full bright. Oh, what do I have? Syntax error. Yeah, so that's full bright. Let me see if I can kill this light here. Maybe make it easier to see. Yeah, so I mean, this is pretty bright. You know, obviously the camera is doing a bunch to kind of screw with the lighting here, but you know, you can definitely see this. Yeah. Let's see what. Let me try wiring up this strand lighting here and see what we get. Okay. So I guess let me kill the power here. And we will pull this board off here. Yeah, let's just take this off for now. Now these LED strips have they're directional, right? So you want to make sure you're going. They have an arrow on them, which I'm sure you can't see now, but the arrow indicates the direction of data travel. So you want to make sure that you wire it in that direction so you don't kill your strip. Let's get a couple of alligator clips here. And so like it's basically the same wiring scheme as that smaller strand there. 2 grounds, power, and data. Let me switch to a different view here. So we're going to need a couple of jumpers. So this has a little, I'm not sure what the specific type of connector this is, but so you have to basically just stick a jumper into the end of it. And we'll stick little alligator clips on the end of these things. Okay, white, we got data. Yeah, this is basically going to be a wiring mess for a minute. Alright. Put our other ground. And our data pin. If I can see. And then power. Okay. So this is a significantly higher density strip, so we should in theory see you know, more amps being pulled. If I can get this set up right. There's not really an easy way to do this. Okay. So let's, I'm going to change our strip length here. It's 144. We're on the same data pin, and then we'll just upload it. Alright, so the code's up, and let's, I guess, add power. Yeah, and you can see as the strip is going down, well, you can't see, let's see here. So the strip is slowly lighting up. It's basically like an LED wipe. You can see we're basically getting to the end here, almost there. So it's like each one of these things is drawing, I don't know, half of a milliamp something. Okay, so at the full strip at 5 volts, you know, what, we're 1.17 amps, which isn't bad, right? This is again highly dense strip. So let's see if we can't get it to strobe and see what our what the amperage looks like. Okay, strip fill here. I think the strip fill will accept the same inputs. And then I think to turn it off, we can do a delay here. And then we can fill again, but at 0. Okay, I mean this is really kind of ugly code, but it'll do what we want it to do, at least for now. Let's see what happens if this flashes or doesn't flash. Okay, well, that did not do what we wanted it to do. Let me see. So I think if we set this, may be easier if we do like if we just set some variables here at the top. So I'll just say, I guess, on. So the input params for this strip.color are RGBW, right? So, and it's obviously out of 255. So all we're saying here is we're setting the off variable to, black, which is effectively off, and then the on variable to full white on all LEDs. Okay, I guess we can do that. That's good for now. So I guess when we start, let's actually create another variable here. Let's say, let's do red. And then green. So right, so RGB, so red full, and then here we'll do green full. Just as some kind of default variables. Okay, so let's say on every let's do it like on 4 iterations, I guess. So what we're gonna do is try to strobe it 4 times and then have a delay. And then have a delay, right? So it's like a strobe and then off, and then strobe and then off. So let's say we'll start it being off. And then we do strip.show. Let's delay 50. The delay takes an int, and that's a microseconds delay. Something I read this week is that delay actually varies in length depending on the board, and that the recommended use would actually be milli, which is an actual millisecond value. So I may actually end up switching to that. So let's say we'll fill it to on strip.show. Strip.show just basically draws your values out onto the LED strip, and then delay 50 again. And then what we'll do is we'll say let's fill it with red after this is done here. Red, and then we'll delay 2 seconds. Well, let's say 1.5 seconds. So in theory, this is kind of like the pattern for like one of the navigation lights, right? So flicker, strobe on and off 4 times, and then fill red, so hold steady red. So this would be basically the navigation light. So let's see what happens here. Let's validate this. I don't think there's any issues. Okay. And we're uploading. And there we go. Okay. Well, we got a strobe happening. It's not... oh, I didn't do a strip.show here. There's our problem. Upload. There we go. Yeah, alright, so that looks pretty good. mean, you could even do like 6 flashes. Maybe that looks better. Because I guess it would be on and off, yeah. So I think 6 may look better. 5 or 6. Yeah. Okay. So, I mean, looking at our amp meter here, you know, when it's full red, it looks like it's at, you know, I don't know, what is that? Basically almost 0.4 amps or 4 milliamps. And then whenever it strobes, it looks like it's not going really above like 7 or 0.65 amps, which is pretty good. And I mean, you could even adjust the delay, I guess. To conserve battery, but you know, again, this is, you know, we're strobing like a full strip, which is, I guess you could do it if you wanted to, but yeah, I mean, actually, I think that would kind of look pretty cool. But you know, in theory, at the minimum possible implementation of this, it would be, you know, a few strips of, so maybe like 16 maximum LEDs, right? 2 strips on each side of your crossbar, basically one side for left and one side for right. Or top and bottom, whatever you wanted your configuration to be. So if we can actually simulate that. So let's limit our LED count to, if we did 4 on each side, and each LED strip has 8, so 8 times 4, so 32 times 2, so 64 basically LEDs. Let's see what our power consumption is. So that would be 8 LED strips. 1 on each side, on either side of the motor. I need to clear the. I need to clear the. I need to clear the end of the strip there, so it's not giving me really an accurate value. Oh man, didn't like that. Okay, let me do it in code, I guess. So let's say 144. And let's say strip.fill off. And return. Okay, so we're all off there. We're a bit high on the voltage. So that's interesting. So even at off, we're pulling 0.1 amps. I don't know if that's from the, because I think the board is being powered by USB right now. So now that that's off, let's set this back to 64 and see what I draw. Yeah, there we go. Yeah, so much lower, right? So this would be the number of LEDs, I guess, used in, you know, like it's not even a minimum scenario. I guess a minimum scenario would just be like 16 LEDs. But you know, this would be wrapping 4 sides of 2 crossbars, which I think, you know, you'd be visible basically from every angle, no problem. And this is like ridiculously bright. Yeah, and it looks like, I mean, the power consumption is like, it's never really even hitting like 0.4 amps, which is, you know, which I think is more than reasonable. I mean, with a 10,000 milliamp hour battery, I mean, this thing could run like a really long time. Yeah. You can see, and it's what did I say this thing was at? 2.4 amps maximum output. I mean, yeah, this battery pack would have no problem powering this strip. I mean, I'm not even, honestly, I'm not even regulating current right now. I mean, if I bring the current regulator down, I mean, I think it's just going to cut off. Yeah, it's just going to cut off. Yeah, I can't even regulate the power low enough on this. Yeah, so I think this is good. Yeah, I think this is good from a power consumption standpoint. And you know, even with the full strip lit on 44, you know, this battery's about to die on this camera. So even with the full strip lit, you know, we're basically just at 0.65 amps, which again is completely reasonable for this little battery pack to power, especially since these things aren't going to be all on all the time. I mean, I think giving you the option to have them all on all the time is definitely something that I would like to see out of this project. But you know, even having it on full brightness, what did we measure? I don't even remember. It was like right above an amp, right? Which again is well below the threshold of again this battery pack. And you know, you can get battery packs that power more, that push out more than 2.4 amps, or that are willing to handle more than 2.4 amps. So this is good. So I think this is a good starting place. I don't know how long my stream has been going now, but I think I'm going to end it here for today. Yeah, I have the I think I have the platform now, so that on the next stream we can start thinking about breaking this into multiple modules, and how we can get different patterns, and then what the pin outs and the wiring look like, and you know, adding control buttons and things like that. So I think that's it for today. So I guess thanks for having a watch. Definitely, if you have some feedback, questions, or comments, leave them in the comment section below. I'm going to probably be uploading. I don't know if these stream videos save, but I know I am recording a version of it. So I'll probably be either uploading the version that I have, or I guess if it saves, just leave some comments down in the comment section. And yeah, thanks for watching. See you guys soon.